Bright Tuty. Every student matters.
With the discovery of electron and proton, it became very evident that an atom is not indivisible, it is divisible. And there are two subatomic particles that were visible and known to us, and that is negative electron and the positive proton. Now, Thomson, what did he do? He tried to formulate a model for the atom, and he said that atom has both the electron and proton uniformly distributed. That is, there is a positive mass and then the negative electrons are embedded in it. And because of this, the total amount of charge in the atom is 0 because the protons and electrons are uniformly distributed. Taking this, considering this, Rutherford carried out the experiment, and he also believed that what Thomson had given, the atomic structure, was to be true. So he carried out the famous experiment that is known as the alpha ray scattering. Now, what is alpha ray scattering? What did he do in this? He took gold foil. He took a very thin foil of gold foil, and the reason why did he take gold was because gold is the most malleable and ductile metal, and it is the only metal that can be beaten down to a very, very thin sheet. So taking that into consideration, Rutherford selected gold foil.
Discovery of the nucleus, Rutherford's experiment. In order to test J.J. Thomson's atomic model, Rutherford set up the following experiment. He reasoned that if positively charged mass present within the atom is thinly spread, then any positively charged particle moving with sufficient kinetic energy would easily penetrate through it. Thus, if a thin foil of gold is exposed to fast-moving positively charged particles, then the particles should just pass through the foil. These particles can be detected by zinc sulfide screen placed behind the gold foil when scintillation are produced on the screen. Rutherford selected alpha particles as missiles to hit the atoms. Alpha particles are the nuclei of helium, He2+, having a mass of 4 AMU and 2 units of positive charge. It is a nucleus consisting of 2 protons and 2 neutrons. The alpha particles were obtained from radium and then accelerated. These accelerated particles were condensed to a narrow beam by passing them through positively charged parallel plates. They were finally directed against a very thin gold foil placed at the center of a circular zinc sulfide screen. Rutherford expected the alpha particles to pass through the gold foil and produce bright scintillation at the point. However, to his surprise, some of these scintillations were produced in regions BV and CC. These observations can be explained only if we assume that positive charge in the atom is concentrated in a very small place within the atom. Following is the summary of Rutherford's experiment. 1. Most of the alpha particles passed through the foil straight without suffering any change in the direction. 2. A small fraction of alpha particles deflected through small angles and few through large angles. 3. 1 out of 12,000 particles appeared to bounce. In words of Rutherford, this result was almost incredible, as if you fire 15-inch shell to a piece of tissue paper and it comes back to you. Rutherford called this concentrated positively charged mass within the atom nucleus and the particles present within the nucleus nucleons. When alpha particles approach this concentrated positive mass at right angles, they get deflected almost through 180 degrees. However, if they pass very, very close to the concentrated positive mass, they get deflected through large angles. Much the same, if they pass just close to the concentrated positive mass, they get deflected through small angles, but if they do not pass close to the concentrated positive mass, they just do not get deflected. That is, they just pass through the gold foil. as most of the alpha particles are able to pass through the gold foil, producing strong scintillation at A, the following conclusions can be drawn from the experiment. First, the nucleus of an atom is positively charged. Second, the atom on the whole is relatively empty and the positively charged mass in the nucleus is concentrated over a very small space. Third, nucleus of the atom is very dense and hard. Fourth, the angle through which alpha particles get scattered depends upon the angle at which they approach the positively charged nucleus of the concentrated mass. Drawback of Rutherford's atomic model. The comparison of electrons to the planets in the solar system is the main drawback of Rutherford's model. It has been found that if an electrically charged particle revolves around a circular path, then it always radiates out energy. Thus, if an electron moves around the nucleus, it must continuously radiate out energy and hence gradually move towards the nucleus in a spiral path till it collides with the nucleus. However, we know that the atom is very stable. Rutherford's model cannot explain this stability.
So he had three observations. The first observation is that most of the fast moving alpha particles passed straight through the gold foil. That is, they did not show any deflection. The second observation was that some of the alpha particles were deflected by the foil by small angles. And he was astonished to see this. Whereas the most surprising thing was that surprisingly 1 out of every
12,000
particles appeared to be rebounding, and that too it started rebounding by 180 degrees. Now that was really very surprising, and Rutherford had put up it in a very nice manner. He said that it is something like the observation made him feel that as if you have got a tissue paper in front of you and you take a pistol and start bombarding the bullets towards it. What would be your expectation? Definitely you would expect that the bullets will straight away pass through the tissue paper. But he was surprised to see that this tissue paper rebounded some of the bullets. So this experiment absolutely changed the concept of atomic structure which Thomson had formulated. Because according to Thomson, both the positive and the negative charges are uniformly distributed in the atom. And thus, because of this uniform distribution, they tend to be having a neutral charge. That is, their atom is electrically neutral. But what observation Rutherford made through his gold-foiled experiment, he found that the alpha particles which was bombarded against the gold foil showed deflection, and some, that is, out of
12,000
particles, one rebounded back to the angle of 180 degrees. So that completely revolutionized the concept of the structure of atom. Fine. So I hope you had clear about it, that what was the experimental setup like and what was the observation made by Rutherford. And because of his observation and experiment, Rutherford was given the Nobel Prize for Physics in the year 1908 because it was a greatest discovery. So through these observations, Rutherford postulated and formulated that alpha particle scattering experiment. He concluded that most of the space inside the atom is empty because most of the alpha particles passed straight through the gold foil without getting deflected. Now that happened because of the first observation. In first observation, what did he observe? That most of the fast moving alpha particle passed straight through the gold foil. Now when can that happen? It can happen only when most of the space inside the atom is empty because most of the alpha particles passed straight through the gold foil without getting deflected. So definitely it must be empty, and it allowed the alpha particles to pass straight through without any kind of deflection. That was the first conclusion that Rutherford had drawn from his alpha ray scattering experiment. The second observation, or the second conclusion that he made from his second observation, was that very few particles were deflected from their path, indicating that the positive charge of the atom occupies very little space. That means the positive charges are basically not scattered throughout or not uniformly distributed throughout the atom. It is rather concentrated in the center. And it is because of this, most of the alpha particles passed straight through it. Very few particles showed deflection from their path, indicating that the positive charge of the atom occupies very little space. That is, if we have to give a diagrammatic representation, then this is what the atomic structure of atom would be. That is, most of the parts are empty, which allowed the alpha particles to pass through it. Second observation, according to the second observation, the second conclusion that was made, that the positive charge of the atom occupies very little space and it is centrally located, due to which some of the alpha particles got deflected by a very small angle. And the third most important was the conclusion that Rutherford made, that a very small fraction of alpha particles were deflected by 180 degree, indicating that the positive charge and the mass of the gold atom were concentrated in a very small volume within the atom. So that happened only through his third observation, that is surprisingly 1 out of every
12,000
particles appeared to rebound back, and that too the angle of deflection was 180 degree. So this observation made Rutherford conclude that a very small fraction of alpha particles were deflected by 180 degree, because the positive charge and the mass of the gold atom were concentrated in a very small volume within the atom. So when
12,000
alpha particles were bombarded against the gold foil, one of them got deflected by an angle of 180 degree, because this is positively charged. So this completely revolutionized the structure of an atom by the introduction of a centrally located positive unit, and later on he termed it as nucleus. So whatever Thomson had explained about the atomic structure, that electrons and protons are uniformly distributed throughout the atom, was discarded by Rutherford's alpha ray scattering experiment, because experimentally it was proved that the positive and the negative charges are not uniformly distributed. Rather, the negative charges are in the outermost place and the positive charges are concentrated in the center. From this conclusion, we can find out and put forward the nuclear model of an atom, which is famously known as Rutherford's nuclear model of an atom. So, the first part of the model of an atom is that there is a positively charged center in an atom called the nucleus. Nearly all the mass of an atom resides in the nucleus. Because when we saw with the discovery of electron and proton, we had also compared the mass of electron and proton. Though both carry the same charges, but their masses vary. Electrons are very, very lighter in comparison to that of proton. So proton being very heavy, the protons are located in the center. So when we calculate the mass of an atom, then the mass of an atom is almost the mass of all the protons that are present in the nucleus of an atom. So this is the nuclear model, where you find that the centrally located nucleus and this is positively charged. Why is it positively charged? Because it contains the positive protons. The electrons revolve around the nucleus in well-defined orbits. So, Rutherford also gave in his nuclear model that the electrons are revolving around the nucleus. And because they are very, very light, so when we calculate the mass of an atom, it is almost the mass of the nucleus. The third is the size of the nucleus is very small in comparison to the size of the atom. And because the size of the nucleus is very small, that's why the nucleus is centrally located, and when alpha ray particles were bombarded against the gold foil, we found that out of
12,000
particles bombarded, only one got deflected by 180 degree because it had an head-on collision with the nucleus, whereas most of the particles passed through because it is empty, and electrons allowed the positively charged alpha particles to pass through it, whereas some of them showed slight deflection only when they slightly touched the surface of the nucleus. And as because the nucleus is positively charged, protons are positively charged, so they repelled each other, and it was because of the repulsion that they got deflected by small angle. But when these alpha particles had head-on collision with the nucleus, the compact mass of the nucleus did not allow the alpha particles to pass through it. In fact, it rebounded, it repelled back completely by an angle of 180 degree. So Rutherford's model gave the ultimate nuclear model of an atom, and as I already mentioned you, in the year 1908 he was awarded the Nobel Prize for Physics for the discovery of the nuclear model of an atom. So let me repeat it once again. On the basis of his experiment, Rutherford put forward the nuclear model of an atom. The nuclear model of an atom goes as: there is a positively charged center in an atom called the nucleus. Nearly all the mass of an atom resides in the nucleus. Second point, the electrons revolve around the nucleus in well-defined orbits. And the third, the size of the nucleus is very small in comparison to the size of the atom. So, because the size of the nucleus is very, very compact, it almost carries the entire mass of an atom. And the nucleus is positively charged, which contains all the protons, and the electrons are revolving in the orbits around the nucleus. So, from this experiment, Rutherford's gold foil experiment, the nuclear model of an atom was given. But there were a lot of controversies that happened after the Rutherford's model of atom or the nuclear of an atom was given. Now, what is the basic drawback in Rutherford's model? The basic drawback of Rutherford's model is that the revolving electrons would lose energy and finally fall into the nucleus. Now, the question is, how does it happen? Now, according to Rutherford, we have the centrally located nucleus. So, there is centrally located nucleus, and around the nucleus is the well-defined orbit in which the electrons are moving. Now, these electrons are negatively charged, whereas the protons are positively charged. That is, the nucleus is positively charged. Now, for any electron, for any charged particle to be in its well-defined orbit, it gets influenced either centripetally or radially by the force. So, when a charged particle is revolving around another charged particles, what it happens, in order to remain in its orbit, it gets influenced by radial force or by centripetal force. But due to this continuous movement, it would gradually lose energy. It will gradually lose energy in the form of radiation. So when it loses energy in the form of radiation, it will become weaker, and these electrons are bound to come closer to the nucleus because the negative electrons attract the positive, get attracted by the nucleus, and then there is every possibility of these electrons collapsing with the nucleus. So it was the major defect that happened in Rutherford's nuclear model of an atom, because he could not explain as how these electrons are revolving around the nucleus. The second drawback is he did not specify the number of electrons that would be in each of these well-defined orbits. So these two drawbacks was corrected by Niels Bohr.